Alright, we are going to now go into the notes for lesson 9-5, the last type of transformation, and this will be dilation. And dilation will simply be an image that either gets bigger or smaller. With the dilation, there's two important things that you got to know about. That is, where is the center, not necessarily like the center of a circle, but like where does this growth or shrinkage occur? And then also, more importantly, the scale factor. Well, how much bigger is the new picture, the new image going to get, or how much smaller is it going to get? Speaking of scale factor, let's take a look-see at this. The scale factor is a comparison. You're always going to have the original figure, the pre-image, and the new image. And, you know, you would just take a side length and compare new to the original. So this would be the scale factor number here. New over the original. If this result is bigger than 1, the figure is an enlargement. If it is less than 1, then it is a reduction. Okay, let's go into problem number 1 here, and we'll show dilation work. It says quadrilateral J prime, K prime, L prime, M. This actually should be a prime here. I don't know, it doesn't come out that way. Is a dilation of quadrilateral JKLM. Describe the dilation. Now, when they ask us to describe the dilation, let me focus this. They want two things, really. They want the scale factor, and they want, is it an enlargement or a reduction? Okay? So we're going to be doing two things when we ask to describe. So, first of all, the pre-image is JKLM, and if you look at this picture here, JKLM, and the dilation is J prime, K prime, L prime, M prime. What you'll right away notice is that the four-sided figure got reduced. So we're going to, when we're asked to describe it, we're going to say this is a reduction. It got smaller. Okay, but now the question is how much smaller? And this is going to be the scale factor, and we'll just say SF for scale factor. The scale factor of this figure. Now what you're going to do is compare the side length here. Now you can take this side here on the left with this side here on the left, or maybe you can pick this bottom side with the bottom side. The problem with some of these comparisons here, like if I decide to go top with top, you'll notice that all of those are kind of at a slant. The actual best side to compare is this one that's in pink here, just going straight up and down, straight up and down. And because you can just flat out count straight up and down. So the big original pre-image is 1 space, 2, 3, 4. This pink line is 4 spaces, and this pink line on the dilated figure is 1, 2. So it's 4 to 2. So now, when you do the scale factor, you always put the new image first. The new image on top, and then the original pre-image on the bottom. So the new image is the smaller one, J prime, K prime, L prime. So that's 2, and then the original is 4. And 2 to 4 is 1/2. So this thing is half the size of the original bigger one. It is reduction. It reduces. Okay? Again, I could have done little a squared, b squared, yellow squared, a squared, b squared, yellow squared, and gotten some numbers here, but everything would reduce down to the same scale factor because every size is going to shrink at the same rate. Okay, so it's not like, well, what about this side here? It would still get to 1/2. All right, let's do number 2. Number 2 is kind of a just a basic word problem, really, that does do a comparison of one figure to the next. The height of a tractor-trailer truck is 4.2 meters. The scale factor of a little toy model is 1 to 54. So obviously it's smaller. Whenever you have a scale factor that is less than 1, between 0 and 1, it is a reduction. And of course a model toy is going to be smaller than the real toy, the real truck. Find the height of the little toy model to the nearest centimeter. Okay, so we got a big truck of 4.2 meters. Well, let's first, because they want this in centimeters, let's convert this into centimeters. 1 meter stick is equal to 100 cents. 100 cents make $1. 100 centimeters make a meter stick. So all I would do is go 4.2 times 100. This is 420 centimeters. That is the real truck. Okay, that is the height of the real truck. So now we have a toy model that is 1/54th of it, or basically 54 times smaller than the big truck, and then rounded to the nearest centimeter. So the little model, all you got to do is take the actual height of 420 and basically multiply by the scale factor of 1/54. Now this, by the way, has the same effect if some of you thought, well, all you got to do is divide by 54, and that is correct. 420 divided by 54. Whether you multiply by the fraction or whether you just divide by 54, you will get the same result here. 420 divided by 54, 7.77, and they say rounded to the nearest centimeter, so we'll have to go 8 centimeters. 8 centimeters. Either way. Okay. And finally, let's do one here, number 3. It says, find the image of triangle PZG for a dilation with center 0, 0 and scale factor 1, 2. Okay, so here is the pre-image, and we are going to draw a new image. Now this part here with center 0, 0, all the problems are going to say this. You don't really need to worry about this, because this triangle is going to shrink or grow. In this case, it's going to shrink because the scale factor is 1/2. But basically, when it says center 0, 0, you could have a smaller triangle, but where do you put it? I mean, do you put it way over here, or you put it here? Well, this center here, basically means it aligns with 0, 0 right here. You don't even have to think about this too much, because that will always be the case. But here's that is important. It is a scale factor of 1/2, which means because it's less than 1, it's a reduction. We are going to draw the new image. It's going to be a small little image there, a triangle. Of course, we're going to make a triangle half this size, but where does it go? I mean, where is it? So what we're going to first do is get the original locations of P, Z, and G. So let's look at point P here. Now, if I look at the grid chart here, it looks like 1, 2, 3, 4, but you got to be careful. This is in increments of 2. So this is 1/2, 1, 1.5, 2. So it's 2 over, 0 up and down, P. Z here, again, it's -1/2, 1, -1, comma, and it goes only up 1/2. 1/2. Because here is +1 after 2 spaces. And again, this is +1/2, 1, left to right, and it goes down to -2. Keep in mind that this chart is in spaces of 2. All right, so now where do I put this reduced triangle? Because I know I'm going to have a smaller triangle. I mean, should it go here? Should it go here? And how do I know that I actually made it half the size? Well, if you just get the original locations, all you're going to do is take this scale factor of 1/2 and multiply it by all the coordinates. And what will happen is, once you plot the 3 new points and connect the dots, everything will grow or shrink for you. So you don't even have to think about it. All you're going to do is just take this half for P. 1/2 times 2 is 1. 1/2 times 0 is 0. Do the same with Z prime. 1/2 times -1 is -1/2. 1/2 times 1/2. This is 50 cents. What's half of 50 cents? That is 1/4. So 1/4. 1/2 times 1 here for G prime is 1/2. And 1/2 times -2 is -1. So all I did was take the original locations, multiply it. But now when I plot it, and remember this graph is in increments of 2, what will happen is when I connect the 3 dots, you will see a little baby triangle here. 1 over, 0 up and down. So there is point P. Point Z, I shouldn't have put that dot there, but point Z is -1/2. Again, that's just here. And then 1/4. So it's kind of right here. And then G is +1/2, which is right here. And then it goes down -1, -1/2, -1, right there. Again, I wish I didn't put that little dot there at 0, 0, but I did. But when I connect these 3 dots, not the 0, 0 dot, this is G prime, by the way, and this is Z prime at the top left corner here. Now you see the little triangle here, and I'll highlight it here, it is half the size of the original. Each side length got shrunk in half. And not only did it get shrunk in half, because you're on a grid chart, it literally plots it for you when you do the multiplication. Okay? If this was a scale factor of 3, meaning 3 times bigger, you would do the same process. 2 times 3 is 6. 0 times 3 is 0. But then when you plot the 3 new points, you will notice a triangle 3 times bigger. All right, and that is lesson 9-5.